The expression above is equivalent to a over x plus 2 squared, where a is a positive constant and x does not equal negative 2. What is the value of a? We need a common denominator to subtract these two fractions. The least common multiple of x plus 2 and x plus 2 squared is x plus 2 squared. So to scale up the fraction on the right, we need to multiply it by x plus 2 over x plus 2. Because x plus 2 over x plus 2 is equal to 1, we're just changing the form of the fraction without changing its value. I know some of you will want to square 2 over x plus 2 to get your common denominator, but that would change the quantity of the fraction, so don't do it. Let's proceed. We'll multiply straight across and distribute that 2 to get 2x plus 4 over x plus 2 squared. Then subtracting the fractions gives us 2 over x plus 2 squared. That must equal a over x plus 2 squared, so a is 2. The expression 5x minus 2 over x plus 3 is equivalent to which of the following? First off, don't even think about canceling those x's. There's nothing in common to all four terms in this fraction, so the fraction doesn't reduce. Answer choices A and B are trap answers for those poor souls who committed mathematical crimes and tried to cancel the x's. So let's look at answer choices C and D. If we make 5 into a fraction, then we can scale it up to get a common denominator. Then distributing the 5 gives us 5x plus 15 over x plus 3 minus 2 over x plus 3. Then simplifying, we get 5x plus 13 over x plus 3, which is also not what we need. But if we subtract 17 over x plus 3, as in answer choice D, we do get 5x minus 2 over x plus 3. Which expression is equivalent to y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus 8xy? This is a particularly interesting problem because it brings out a frequently overlooked subtlety of simplifying fractions. First though, let's think about how to add these fractions. To find a common denominator, let's first try to factor the existing denominators to see if they have anything in common. A moment's inspection reveals that we can pull out an xy from the denominator on the right. That gives us y times x minus 8 divided by xy times x minus 8. Now, it's tempting to simplify this fraction by canceling those y's, but we actually can't do this since it would change more than just the form of the fraction. It's not obvious why, so consider a more straightforward example. Take the function f of x is equal to 3x squared over x. X equals 0 is not in the domain of this function, whereas if we were to cancel those x's, x equals 0 is in the domain of g of x is equal to 3x. These functions may look similar, but they are different because one has a hole in it and the other doesn't. Similarly, on our example from the SAT, y equals 0 is not in the domain of the original function, but it is in the domain of the reducer function. Therefore, these functions are different. You cannot cancel that y. In general, you can only simplify a fraction if you know that what you're canceling cannot be 0. So with that settled, let's go ahead and multiply the left fraction by xy over xy. That gives us xy squared plus 12xy divided by xy times x minus 8 plus xy minus 8y over xy times x minus 8. Then finally, putting these fractions together, we get xy squared plus 13xy minus 8y over x squared y minus 8xy, which is C. If x is greater than 3, which of the following is equivalent to 1 over x plus 2 plus 1 over x plus 3? People get into trouble on this when they vaguely remember the phrase keep, change, flip, but fail to understand that this is not the appropriate situation to use that magic trick that they learned 10 years ago. Instead, let's proceed in the only way we can, which is to add the fractions in the denominator. To do that, we need to find the least common multiple of x plus 2 and x plus 2, which is simply the product of the two. So let's multiply this left fraction by x plus 3 over x plus 3, and the right fraction by x plus 2 over x plus 2. That gives us 1 over x plus 3 divided by x squared plus 5x plus 6 plus x plus 2 over x squared plus 5x plus 6. We'll add these fractions in the denominator to get 1 over 2x plus 5 over x squared plus 5x plus 6. Then multiplying the top and bottom by the reciprocal of the denominator gives us x squared plus 5x plus 6 divided by 2x plus 5, which is b. Which of the following gives p in terms of m, r, and n? At first blush, this looks like an intimidating problem, but it actually requires only a single algebraic step. Let me start with a simpler example. Suppose we have that m is equal to 3/5 p, and we want to solve for p. We're not going to divide by a fraction. Instead, we're going to multiply by the reciprocal of 3/5, which is 5/3, and that leaves us with p is equal to 5/3 m. Problem 7 has the same structure. All we need to do is multiply both sides of the equation by the reciprocal of this nasty looking fraction, and we get answer choice B. If everything here made sense, then you're clear to move on to my next video on exponents and radicals.